Hello there and welcome back to the Code Wrinkles channel for a brand new video in which we will actually try to answer some very tough questions. Like, what is actually a rich domain model? What does this even mean and why is this useful? And I think that this is a very important topic to discuss about because everybody says that, okay, rich domain model is great, having an anemic domain model is not so great, so we should actually try to tend towards a rich domain model. But in the end, when you start to look at different applications, you will see that even if the theory says that, okay, we should use the rich domain model, it's fairly often happens that we actually don't. And that's why I think it might be useful to take a look into what that means, and we will start from some code that I have already prepared. And before I get into it, I just want to say that I have extracted this kind of like example from a real application that I was working on, a real production application. Of course, due to obvious reason, I cannot use the code from that application directly to actually showcase different problems that we might have. So I have stripped down everything to some very basic stuff that is very similar to what I had in that application and what refactoring needed to be done there. So let's start to look into that. And we were working, for instance, of a payment on a payment request software, or a software that would actually handle payments that need to be done to different customers of that certain company. So the idea is that somebody would create a payment request with a lot of different details in it. It would have to go through different authorization stages, and in the end, in the finance department, or a person from the finance department should give a last approval on that. And of course, after that, the payment would have to be processed by the bank or sent to the bank to be processed. And that's actually the very basic use case. And I'm sure that if you are working on business applications, this is a certain scenario that you might encounter fairly often. So it's really not uncommon. And I guess most of people can relate to that because it's not a very niche domain. It's something that you will probably have to deal with in most of the applications that you are working, or at least in a lot of the applications that you are working on. And here is the model for this kind of application, which is the most important model for this functionality, which is the payment request. And if we take a look at this payment request, and once again, the real payment request that I had to deal with was much longer than that. It included more properties, but in order to keep it as short as possible and to showcase what we actually want to do during this refactoring towards a rich domain model, I have only use some properties that kind of like make sense to have a basic functionality here. And the first thing that if we review here this kind of class or our model, well, we see that we just have a bunch of properties here on the class, and all the properties are, well, with get and setters, and everything is as said, as you might encounter in a lot, I would even dare to say most of the applications out there, and everything seems to be fine here. However, what we have here is actually what we call an anemic domain model, because this domain model right now just has a bunch of properties and nothing else. It's anemic. It doesn't really do anything. It just provides us some properties that probably we might just use to actually persist things in the database, and that's not really the scope of a real domain model. But why is this the case? And let me try to walk you through a basic setup that, as said, you might encounter in most of the applications. So you have this model, which is an very anemic domain model because you just have some properties here. So that's what this means. Now, if we go a step further, probably you will have some repositories or working directly with some database access layer, but then you would have services for your business logic. And here, for instance, you might have this payment request service. And in this payment request service, we have this method that creates a payment. That takes in a string for the IBAN code, a double for the amount, and does here a lot of stuff. And we really don't have to really focus on what exactly happens here, but that's the logic that might happen or that is used when it comes to actually creating a new payment request. Then there is this other method, which actually means submit payment request, when the user wants to actually make a submit on that. And what does that even mean for our domain? and that is what we handle here in our service. However, then we have also maybe a bank processing service. And in this bank processing service, you might have this complete payment method that kind of does all the business logic that should put this payment on a completed state. But then we might have another payment authorization service. Right now, this I haven't populated with any method, but the idea is that here you would have different actions that different authorizers might be able to perform on a certain payment. And the fact that we have here 3 services that kind of like work with the same type of resource, that's already some very good thing, because we have tried to split different things that you could perform on a payment request and group them logically in different services. Because what most of the time will actually happen is that you will have one single service, because that's what you start from, and usually you won't have any time for refactoring because customers usually don't want to actually invest that time. And then you end up having here in this payment request method a lot of different methods for everything that you can perform on a certain payment. Now, that's really the basic setup that we have right now. And once again, you would encounter this setup, I would say, maybe in most of the applications. Now, what's the problem with this setup? And let's start from this program class. And let's imagine that this program class is the consumer of our model and of our services. So that's really the consumer. In this case, it's a console application. It would probably just display something to the console, but that's really not important. However, there are 2 very, very big problems with this setup that we have right now. And these problems really amount for a real big amount of bugs that you might have in your application throughout its lifetime. When you add new functionality, or when you have to update certain functionality, you might most always have certain bugs due to this exact setup here. And let me show you what exactly could happen, or what those 2 problems is. So the first big problem here is that, okay, we are here in the consumer of our model and of our services. Now, here we have the service, we get a new instance of the service. Normally in ASP.NET Core, you probably will get this through dependency injection, but that's really not the scope for this video here. And then we use the service to create a payment request, okay? And here I'm the consumer, and okay, I'm looking into this payment request that was created. But I don't know, maybe something doesn't seem right to me. So what I will see here, a request, and say maybe last update date, or last update date equals, how was it, request last updated date equals, and let's say date time now. Now, what we have done right now is actually that during this create payment, we have already set this last update date to be at a datetime now. But probably a few milliseconds afterwards, what we do in the consumer here, we do this update once again. And this already puts our service or our request in a state that it is not valid, because right now we have just changed the last updated date with no obvious reason. Of course, the consumer could have its reasons, but they are not business rules reason. So from this point of view, we can say that the consumer just has changed this for no reason, and therefore right now this object, this request, is not in a valid state, because the datetime now that we have set right now doesn't correspond to exactly what happened when that request was created. But we can go even further and say, okay, maybe, I don't know, maybe the amount doesn't really seem right to me. So let's set a new amount, and I would say, I don't know, it's something like that. And obviously, this is a very extreme example, of course, but the idea is that here the consumer is just able to, well, change the amount, and maybe due to a typo or any other reason, it did set this amount to a negative value. Now, of course, obviously, when you want to make a payment, you can't do that. So the value needs to be positive. So once again, the consumer has or was able to just change the amount, and once again, put the model in an invalid state, because of course that should not be possible. So the first problem is that right now in the setup that we have, actually everybody, really everybody in your code can set properties for your model, and it might set on values or to values that put the entire object on an invalid state and wants it invalid from a business rule perspective. However, the application doesn't really know if this is valid or not, and these changes might even go to the database, and you might end up having a lot of bugs and requests, hey, this is not working properly, that's not working properly, because you actually got wrong data in your system, or you were working with objects that were not, from a business perspective, in a valid state. You persisted them, and from there on, it goes only downhill. So that's the very, very first big problem. Now, the second problem is that, okay, what or how can we ensure, for instance, that all business rules are enforced, or that we adhere to the business rules that we actually have to implement? And obviously, the answer to that would be in our services. So we have this payment request service, and as the definition of on how we might use services in a standard layered architecture is that here is the part actually where you want to enforce some business rules. And kind of you already do this, because when you create this payment request, there are some business rules here, like we said the create date, the created by. Probably we take this created by from, I don't know, some token that we have in the application, or things similar to that. Then last updated, then the IBAN, the amount, and of course we could have even here validation on all this type of stuff to make sure that everything is valid when we want to assign this type of values. And that's very fine. But then we have this submit payment. And right now we can see already that in this submit, and we just add something to the status history. And here to the status history, we add new request statuses, which is the submitted. And then we add this submitted status once again. Okay, cool. Maybe that's wrong. Let's change this to the status waiting out. Okay. And okay, we say that would be great. Cool. And now we set also the current status. But you notice what we didn't do here? We didn't set, we did not set the last update date and the last update by. Although we have performed here an update on this request. Now you would say that's once again a very, very extreme example, and you would probably get that during code review. And the answer to this is, in some cases you might, but in most of the cases when you work with real production application, you actually won't. And the reason why you won't is that you have a lot of business logic that is scattered throughout different services. So we have some business logic here, we have some business logic here, and we'll have also some business logic here. And we might even have different other services that will work with a certain request, and all the services will contain some business logic that regard that simple request. And when you have a lot of places that are actually the holders of what valid means or not, the problem is that you can't remember in a team in 1 month, 2 months, 3 months, really everything that you have done, or all the business rules that are scattered throughout the different services or throughout different methods in the same service. So that's for sure not an option, and sooner or later, when your application will get a little bit more complex, you will actually have, for instance, this problem that you might set here something in the bank processing service, but that's something that you set here actually contradicts maybe some business rule that you are using here. And when you are using this type of approach where business rules are scattered throughout an entire plethora of different services or methods inside the same services, you will sooner or later have this problem. Trust me. So that would be the second problem. So the first as a summary, the first problem is that anybody really can change the properties of my model and put it in on an invalid state. And the second problem here is that my business rules are scattered across different services or across a lot of different methods inside the same service. And sooner than later, this will cause us problems, as when we try to update something, it would conflict with another business rules, and we will not 100% be aware of that. And these two reasons are really, I guess, the cause for a lot of bugs that you might have in your applications. So let's take a little bit, or let's take a look into how could we refactor our code towards a rich domain model, which would aim to really solve these two problems. So it would solve the problem that that consumers can simply change the state of my object and put it in a state that it's not valid according to the business rules. And secondly, we'll try to actually make it in a way that we centralize all the business rules in a single place. So we are 100% aware of that. So let me go for that to this payment request model. And the first thing that we would do here is we need to fully encapsulate all the properties and all the information on this class. What does this even mean? It means that this class should the only one be responsible to perform changes to the state of an object that it is instantiated of that. So no outside consumer should be able to change the state of my object. That responsibility should rely only within this class and nowhere else. And how we could even do that is, first of all, we could set private setters here. Private set, let's set private set here, and we'll basically set everything privately. And that's the very first reason why you would use encapsulation. And when we talk about encapsulation, you know, the theory is fairly abstract, but that's here the main reason why we need to do encapsulation, because we want to make sure that the state of this object will only be able to be changed within this object itself and nowhere else. And this is a way that we can actually take charge about what we want to change and actually validate each state change of the object. So let me also put this on private. Let me also set this to private, and let me also set this to private. Okay, and also set this to private. Now, of course, Rider gives me a lot of warnings because we actually are not able to set this from anywhere. Now, the thing that we have done here is, okay, we have set everything to private, and you know what? Entity Framework Core will probably need a constructor, so we could even have here a constructor, private. And that would actually do that. So nobody would be able to create a new instance of payment request except us here in this class. Cool. So this is the first thing. So we fully encapsulated all the properties, so nobody will ever be able to actually change those properties from outside. So this class, just by encapsulating everything, is already responsible for handling state changes of the object. Cool. Now, the thing is, of course, we have set everything to private, but right now, as we have set this up, actually, nobody can change something here, and nobody can even create such a payment request. So what we'll do here is, of course, the first thing that you could do, or the most easy thing to do here, is just for creation, use a static factory method. And of course, if the logic is more complex, you might want to use a real factory or a builder pattern or something similar to that. But the idea is that what we want to do here is we encapsulate all the properties and we encapsulate the entire state of the application, and we expose methods that would allow you to interact with the state of this object. The only good thing about this is that right now, when you want to interact and change the state of the object, we are inside this object itself, and here we can enforce that the change is actually not done if it would put the object on an invalid state, and we can maybe throw an error or something like that. So let me create this public payment request, create a payment, and let's assume that we want to here to have actually a string, an IBAN code, and maybe a string or a double for amount. Of course, for amounts you would probably have decimals. Okay, let's call this amount. Cool. So the idea is that what we'll do right now is we'll go to the payment request service, and what we'll do is we'll simply get all this logic here out of the service and move it into our model. So here we have actually done exactly that. Now we have created the payment request and we return that payment request. And now in the service, First, the service is needed because in services usually don't just create a request and that's it. You also interact with your database because you might want to read it from the database or persist that and things similar to that. Or you might interact with other services or other repositories. So that's why we use services. But in our concrete example right now, we could actually just return payment request and we'll have this create payment. Of course, I have to make this static. I guess I didn't do that, so it's a public static because we want to be able to actually run this method statically. And here it would be create payment. And here, I guess we have some, we can take this information from here actually. And here in the payment request service, we can just place those information and everything should be fine right now. Cool. Now, the thing is we have solved this problem with the creation. Now, the problem that we still have is actually with the submit. And that's actually the exact same thing that we will do. We will actually go here to the payment request. The only difference is that here for the submit, let's maybe just add a comment here and let's say here it's a static factory method, okay? Because when you submit a request and when you want to do an authorization or complete it, all these things that you want to do, they mean changes in the state. So that's why we have here public. That would even return void because we just changed the state of the object. And since this is a reference type, those changes will be reflected. So no reason to return anything here. And submit payment request, okay? So yeah, once again, we have this thing and we can go to the payment request service. And here we can just copy everything out from here and go back to our model and place everything here. Okay, we certainly need here a payment request. Okay. And now we actually do that. And right now we are inside the same class. And here, once again, this is right now the holder of all the business rules. And whatever happens, we have to ensure that everything is on a valid state. And right now, all these rules, the business rules, are not scattered throughout different services anymore. They are all here inside one single class. And here, what it means is that, okay, yeah, I guess we might also need to update these values here. So yeah, let's just update those because we kind of like would need to do that. So yeah, let's just do that. Cool. We are good with that. So if we go to the consumers right now, or let's go to the payment request service, and that would be return. How would it be request dot submit payment? Actually, we don't have to return anything because this returns void. So sorry for that. So no return here. And request. Okay. Be like that. And here in this method here in our request, we would actually not have to do this here. And this happens when you kind of like refactor that, because right now what you want to change are the properties directly here because you have private setters. So in this case for the submit, we will have only status history because we can work directly with the properties. We have once again status history, and here we have current status. And here we take this from the status history and last update date. We just change everything here and we change everything here and we should be good to go. And right now everything should be okay with this one, payment request service. Okay. And right now we should be good. We should be good to do that. And here request, we see that now the consumers cannot really change the state of my object. And here we create a service and then we submit the payment request. And right now, I guess we have solved both problems. And of course, what we have, for instance, in this bank processing service with this complete, that's exactly, we will actually move that also to the payment request service, to the payment request itself, because it's once again logic that kind of like encapsulates business rules, and we don't want to have this scattered throughout different locations. We want to have that in our model directly, because that should be the only source of truth for our domain model in this case. So public, also maybe void, complete payment. Now, what does even mean to complete a payment? Well, it means that we add the status history, and yeah, we add this completed, and we also might want to actually add this or change this current status and the last updated date, and that would actually do that. And of course, in all these methods, you can do a lot of more validation, because you can even check the order of the statuses, that you shouldn't be able to complete the payment before you actually, or before it actually gets through the authorization step, or and things similar to that. So you know that here right now, this domain class, this domain model, as you see, first of all, it's fully encapsulated because you cannot change the state except through the method that you expose, and you have in this case a central place where you manage the entire source of truth for a valid state of your object, which is very, very important. Now, before we wrap this up, there's actually one other small problem that we might have. And the problem here is that, okay, we have set the status history, which is of type list of request status. And it's a private setter. So if we want to go here and, I don't know, say for instance, request.status history equals new list of request status, we can do that. So it's for sure that we really can't do that because it has a private setter. So we are fine with that. But what the consumer can still do here is, well, request status history dot add. Of course, you can have here a new request status, so you can totally do that. And of course, that also means changing or altering the state of our application, and you might be, or the consumers might be adding some request status objects that shouldn't be there because they are not in the correct sequence. So that is really still possible. And that's really a very, very common problem that we can encounter, and we have to be very attentive and careful about that. Because what we want to do in this case is, of course, we should not then have this property as a list, because then we have, or consumers have access to all the methods that the list has, like adding, removing, adding range, and things similar to that. So we don't want to do that. So what we can do instead, we want to have this as an enumerable. And of course, this means that maybe here in our private constructor, what we'll do here is maybe we'll set something like status history equals new list of request status. And then we get a list there. But now this is fully encapsulated. And this means actually that right now, the thing is that, well, internally, you actually use a list for that. So that's okay. But then externally, you just expose that as an enumerable. And of course, what we'll need to do here is, because you might want to add the opportunity for consumers to add a certain status. And of course, in that case, once again, we should do that here in our domain model, because that would allow us to actually even check before we add a status if it is valid to add that specific status at that specific point in time. Now, in order to do that, actually, we have to also add another thing, because right now we expose this, or this property is of type enumerable. So in this case, this add functionality doesn't work anymore, even here for us. So what we'll do here instead, we'll have a private, let me check, a private read-only. Let's have here a list of request status, and that would be, let's call this status history to be consistent, and let's have this new list of request status. So right now we have that one. So what we'll do here in this case is that we won't assign anything here anymore. in the constructor, but instead what we'll do here is we'll use our setters here. So what we'll have here is for the get, let me, I don't know, maybe refactor this just a little bit. And instead of the get here, let's have it like this, return status history. And instead of the setter, we'll set value equals value. However, this could be private set still, and we have to also, okay, so I guess we just have to refactor things a little bit here. It would be like that, and it would be like that. And I guess there's still an error here. Let's just take a look into that. Make field non-read only. Okay, yeah, in this case, maybe we just want to be able to assign it, because even if we do assign it, it's still privately done. So it's still inside our domain model. And that's actually how you want to expose this type of collections in this type of perspective or model, that you you need to be fully in charge of everything that needs to be done here. So cannot convert source. Okay, so that's still a problem here. Cast to liquid. Okay, let's do that. Cool. Now, the only thing here is that when we want to add something to the status history, we don't actually add this to the property itself, but we add this to the field that we have. So we have here for its status history. Should be like that. Okay, what's the problem with that? Let's just take a look here. Make field static. Okay, now okay, because here we have to do this statically here. Okay, because we are in a static method. Okay, so that's something that that we'll do here. Okay, so right now we can add this, and right now this would mean once again that we don't want to do this with the status history, but we want to do this on the service status history. And right now that doesn't really help me a lot. So it would be something like that. And once again, for this one, we just want to have the status history service doing that, and we should be good to go with that. And then once again here, we should change that to work with the status history list that we have here as a private field. And right now, everything is fully encapsulated, because right now, even the consumer cannot add things to this list anymore. And of course, if we want to add something to that list, we might just have here a method public, maybe void once again, add status to history. And then we might have here something like request status. Let's call it like that. And then what we'll do is probably we'll do validate if the status can be added. And then last but not least, we will just add that status. And that would be it. So if you want to remove a status, you would then expose a method to remove the status. And once again, for each type of state changes that might be supported in your application for this specific payment request, you would have to expose a method that actually does that. And let me just maybe here as a summary, make everything shorter here. And that's how we have right now refactored our entire new class from an anemic domain model to a rich domain model. And we have seen right now that we actually, by doing this refactoring, we have solved some very, very important problems. And I can guarantee you that if you go with this approach, you would have less bugs, a lot less bugs in your applications. The reason why you would have less bugs is because we have solved our two problems. The first problem is that no consumer will ever be able to change the state of our payment request. So if a state change is needed, we then expose a method, then consumers show us their intent, what they want to change. Then we can check, validate if that change is even valid, and if it is, then we actually perform that change in the state of the object, like setting the properties or adding something to the status history, and then we persist that in the database. And by doing that, actually we can be almost 100% sure that whenever a payment request arrives in our database, it is on a correct state. So you can't really have payment requests in your database right now that would be in an or on an inconsistent state. And the second problem that we actually have solved right now is that previously we had the entire business rules actually scattered throughout different services and maybe throughout different methods in the same service. And once again, that is a major source of bugs, because in each of them you could theoretically change the state or alter the state of the object, and you might get in conflicts because nobody can really remember all the business rules all the time, and that would cause problems. So to solve that, what we have right now is that when it comes to the business rules and what actually can be performed with a payment request, and those actions should also be valid, everything right now is centralized in our domain model itself. So if you want to take a look at that, you can just go here, and here you have all business rules encapsulated in your domain model. You don't have to check 5, 10 service classes or 100 methods to really get up to date with all the business rules. You just have to check this object, and that would be it. Yeah. And that's actually quite it. That's why actually rich domain models are very, very important. And that's how we can refactor existing code with anemic domain model towards a rich domain model to solve our problems. If you think that this content was useful for you, don't be shy and hit the like button, the thumbs up button, and feel free to share that in your community with your friends, with your peers, wherever you might think there might be an audience that would find that useful. Just feel free to share that and spread the word, and I'm sure they would also appreciate that. Also, if you would have anything to say here, or if you have any questions, or if you have suggestions or maybe feedback, what would you do else, or what are your 2 cents regarding this topic, then feel free to use the comment section and just write your opinion there, and I would be more than happy to get a discussion going. And last but not least, if you haven't subscribed to this channel, then please subscribe to this channel right now, and also make sure to hit the notification bell button so that you are notified whenever we post something new on the Code Wrinkles channel, because we tend to post new content very, very frequently, and you might want to be up to date with that. This being said, once again, thank you very much for watching, and until the next time, I wish you the very best.